This video is going to be for 12.4. This is on writing parabolas. We're going to be looking at parabolas in a different form than we're used to. And I have a few parabolas drawn here, one pointing up and one pointing to the side. We can also have a parabola pointing down and opening to the left instead of opening to the right. I also wrote down some equations for for the parabola that you might have already seen before. This should be a familiar topic since you've talked about it in a couple other math classes. This is going to be the standard form of a parabola, y equals ax squared plus bx plus c. This form here was the vertex form, and this here was the factor form of a parabola. Now we're going to be looking at the conic form of a parabola. And before we go on to that, I just want to show you a couple applications of a parabola. For instance, a satellite dish is a parabola, as well as a headlamp in a car. The satellite dish, the reason it's a parabola is the curvature is that of a parabola, and this little extension coming from the satellite dish at the tip of it is the focal point, or as we know it, the focus. And the whole point of the focus is that when the satellite dish is receiving a signal from another satellite, what it's doing is it's sending the signal into the satellite dish. That signal bounces off the parabola no matter where it hits, and will end up going to the focus. So again, no matter where the signal hits the parabola, that signal will always bounce back to the focus, and the focus allows your TV to actually receive the signal. This is similar for a car headlamp. The bulb is actually placed away from the casing. And the reason the bulb is placed away from the casing is so that when the bulb is actually turned on, the light rays will hit the casing and then bounce directly straight ahead, and that's how the light gets onto the road. So, there are a couple of applications of parabolas, and now let's go and look at the conic form of a parabola. As we've always done before in the previous videos, the vertex is still hk, nothing new there. We are introducing a new variable though called p, and the value of p is going to be the distance from the vertex to the focus. It's also the distance from the vertex to the directrix. And you might have noted the focus is still going to be here for a parabola, but we do have a new word called the directrix. The axis of symmetry, I'm hoping you've seen before, that's the line that's going to cut the parabola in half, symmetrically. Now, let me just draw a picture here. Notice there's a vertical and horizontal. For the vertical, the parabola could be facing up or it could be facing down. For a horizontal, the parabola could be opening to the right or it could be opening to the left. I do not want to restart now. Oh no. Okay, that was technical difficulty. Sorry about that. So the parabola that we're going to be looking at now, one piece that's new to it is that there's going to be a point inside. That's the focus. That's just like the satellite dish. The directrix is going to be this little line beneath it. The distance from the focus to the vertex is a value of p. That's what this statement is saying. And the distance from the vertex to the directrix is also a value of p, which is what this statement is saying. Every parabola has a focus and a directrix. This purple line, this purple dashed line is called the directrix. And the parabola needs the directrix because the definition of a parabola is actually the following. And you won't be tested on this, but it's for your extra information. The distance, if I draw a vertical line from the directrix and just up, it will intersect the parabola at a point. That distance from the parabola's, this distance in blue will be the same distance if I draw this point, if I draw a line from this point to the focus. These two segments are congruent. Every point on the parabola has this property, that if I draw another vertical line from the directrix to the parabola, and then another line from that point to the focus, those lengths will be congruent. The directrix is required in the construction of a parabola. So every parabola will have a directrix. It's important for the parabola to have the directrix because that's how the parabola actually comes into form. Now, for our knowledge, we're only looking at what the equation of a directrix will be. We'll be looking at what the axis of symmetry will be, the focus, and that will be it. Very quickly, the horizontal axis will be the same thing. We'll have a focus on the inside and the directrix on the outside, where the distance from the vertex to the focus will be a distance of p. Similarly for the directrix to the vertex. Let's try a problem. Right away, we should be able to answer what the vertex is, because you've had a chance to do that at least 12 times. -3, -5. The parabola is going to be standing up. The reason I know this is because, number one, x is being squared. So I know that the parabola is going to be either facing up or down. The way that I know it's going to be facing up, though, is I look at this value. 8 is equal to 4p. And again, I have this down here. This number in front of the y minus k is going to be 4p, and that's 8. P is 2. Because p is positive, the parabola is going to be facing up. If p was negative, the parabola would be facing down. But we don't have this case. We have p as positive, so I know that the parabola is going to be facing up. Let me go and plot a couple points here. So I have -3, -5 is one of the points. And again, if I know that the parabola is facing up, a directrix is going to be beneath it, p units beneath the vertex. So if I go down 2 units from the vertex, I'm at -3, -7. That's going to be a dashed line, an invisible line, at y equals -7. The focus is p units up from the vertex, so that's going to be at -3, -3. Again, that's 2 units up, that's the p value, and that means, again, my focus is -3, -3. My axis of symmetry is going to split this parabola in half, and that's going to be going through the vertex at x equals -3. Now, to draw this, we need a couple more points, and the way we'll get those points is the following. The 4p is called the lattice rectum. And what that does on a parabola is it takes the distance, it starts in the from the focus, and it goes a length of 4p. So 4p, the value of 4p in this problem is 8. That means that I have a distance of 8 going through the focus. If I cut 8 in half, that means I'm going to be going 4 to the left of the focus, which gets me at -7, -3. And if I go 4 units to the right, that's going to get me at 1, -3. And these are going to be 2 points on the parabola, which allows me to draw the parabola. And again, this distance that I put here is going to be the lattice rectum. Let's try a problem on your own. Pause the video, resume when you're ready to go. So hopefully you got the following information. I hope you didn't fall for the trick that this vertex is 1, -7. The h is always going to be with the x. So our x-coordinate of the vertex is going to be -7. The y-coordinate is 1. I plotted that point already in blue, so the blue has the vertex. I also did 4p is equal to 12, because 4p is going to be the coefficient of x minus h. P is equal to 3 if I solve for p. And I noted that p is positive. If p is positive, that means that the parabola is going to be opening up in a positive direction, or in the positive x direction. If p is negative, that means the parabola is going to be opening up in the negative x direction, or to the left. So I can expect my parabola to be opening up this way, to the right. What I need to do now is just plot the focus and the directrix. The focus is going to be, again, 3 units away from the vertex. So if I go 3 units towards on the x-axis, away from the vertex, that's going to get me at -4, 1. And let's put this in a different color. -4, 1, this is going to be the focus. The directrix is going to be 3 units underneath that. And again, I know that the directrix is going to be on the left of the parabola because the directrix is always outside of the parabola, never intersects the parabola. So the directrix is going to be at -10, and again, that's going to be a vertical line. And that equation is x equals -10. On your test, do not put down that the directrix is -10. You must state the variable because that tells the direction in which the line is actually going. For the axis of symmetry, we note that the axis of symmetry will split the parabola in half, and the parabola is going to be on its side. So our equation is going to be y equals 1. And this is going to be the axis of symmetry. Now finally, let's go and do the latus rectum. We did have 4p is equal to 12. If I take 12 and I divide that by 2, I get 6. So if I go 6 units away from the focus, I'll get another point on the parabola. So 6 units away from the focus will put me at -4, 7. And if I go another 7 units down, that's going to get me at -4, -6. These are going to be 2 points on the parabola. And that allows me to draw my parabola as such. And again, I'll just note here that this distance is 4p. A straight line going through the vertex to touch either side of the parabola. Here's the fun ones. If you have a general form of a parabola, you're looking to see there's not going to be both x squared or y squared terms. So we have a y squared here. We're going to move everything, keep the y's on one side of the equation, move everything else to the other side. So we'll have -4x plus 33 on the other side of the equation. I'm going to divide everything by -1 to get rid of these negatives. And then I'll complete the square, just like we've done before. So we'll do y squared plus 2y plus 1, and that will be equal to 4x minus 33, and then again I'm going to add 1 because I added 1 by completing the square. This side of the equation will factor into y plus 1 squared. And on the right side of the equation we have 4x minus 32. If I factor out the greatest common factor from both terms, I get 4x minus 8. And now I can tell the key components of this conic, of this parabola. The vertex of the parabola is going to be 8, -1. The p-value, 4p is equal to this 4, so p is equal to 1. I notice that the parabola is going to be lying on its side. P is positive, so it's opening up to the right, which means the focus is going to be going 1 unit to the right, which is going to be at 9, -1. The directrix is going 1 unit to the left, which is going to be at x equals 7. The axis of symmetry goes through the y value, so the AOS is y equals -1. And finally, please pause the video now to finish up the last problem. And I hope this is the answer that you got. It was hopefully a little bit easier in the sense, and maybe that's what made it tricky, is that there was no x term that we needed to complete the square. So it was 1 step reduced. I moved the terms to the other side of the equation, factored out the GCF, found out that p is 5, and that since p is positive, and x is being a square, the parabola has to face up. And this allowed me to find the vertex, the focus, the directrix, and the axis of symmetry by using these equations. Thanks for watching.